Hello everyone, we are going to discuss about the statistics and numerical methods. In that, let me see the application of numerical methods in electromagnetics. The introduction part is by knowing the applications of numerical methods in electromagnetics, we can understand why numerical methods are needed to solve the realistic or the practical problems in electromagnetics, and then we came to know the mathematical concepts upon which computational electromagnetic relies. Then what is numerical methods? It is none other than the it is for the ordinary differential equation, can also be extended to the solution to the PD, that is a partial differential equation. Then the methods such as a finite difference method FDM, finite volume method FVM, finite element method FEM, boundary element method BEM, etc. are commonly used for treating the partial differential equation numerically. All numerical methods used to solve the partial differential equation should have consistency, stability, and definitely a convergence. Then, what is meant by the electromagnetics? As we know already, it is traditionally approached through the jargon and devices belonging to one of many subfields such as electrostatics or optics. In real world applications, it is rarely necessary to consider all possible electromagnetic phenomena that may occur. Instead, a more practical understanding of electromagnetics comes from considering a number of special cases, including electrostatics, steady currents, microwave engineering, and also the optics. Here, the formation of aurora due to electromagnetics. You can see the different color formations which are beautiful. So they are formed due to electromagnetics. It's the known as aurora. Then, as we see the applications of numerical methods in electromagnetics, first application, the relativistic boundary condition for a moving conducting object. Here's is a small graph. So here such conditions are there that one dimensional moving conducting surface illuminated by a plane wave is shown in figure. That this is one. Then the incident electric field is polarized in the x direction and incident magnetic field is polarized in the y direction. Then the equation is E suffix x is equal to V into Q into H suffix y. Then the four condition, that is 2a, 2b, 2c, 2d, they are the relativistic, the boundary conditions, that scattered motion perpendicular to the surface normal results in the boundary condition similar to those of a fixed object. Here the incident wave and the indefinite surface. Then another is numerical results. In order to validate the accuracy of our numerical method and to illustrate the Doppler effect, as we already studied in physics, it's a change in the frequency and the pitch. So, of a moving conducting object, numerical results are presented in this part. That's the solution procedure to gain the electromagnetic scattering properties of a moving conducting object mainly includes two steps. The first step is to calculate the time domain scattered field. Then the second step is to get the frequency spectrum using the fast Fourier transform FFT. Then that's all about it. That conclusion, we reach the conclusion part. It's like it goes on like electromagnetic scattering from a moving perfectly conducting object in the steady state and transient state, that's a broad band, has been analyzed by the proposed numerical method based on the FDDTD theorem. Then by comparing the stimulated results with the theoretical results, the accuracy and validity of the numerical approach are evaluated. It is convenient to analyze the broadband scattering properties of moving bodies. This approach can be applied to many practical engineering problems such as deleting the speed